Hello, my name is Gary Hockwald and I am a member of the PV Solution team. PV Solutions was established for providing innovative solutions based on renewable energy. We focus on challenging installations in remote locations under tough conditions. Our team consists of Israeli and Panamanian entrepreneurs and renewable energy experts with a vast experience in design and installation of off-grid systems worldwide.
Hello, my name is David. I am the Baron Raviv Chief Engineer. Baron Raviv is part of the Baron Group, the Israel's leading EPC contractor for renewable energy projects. The company is specialized in providing turnkey and tailor-made, all-exclusive solutions according to each customer project requirement and specifications. Baron Raviv provides assured quality project management and services informed on engineering, procurement, and construction management contracting services.
Hello, my name is Eli and I'm the project manager of Aligandi. Baron Raviv has undertaken numerous solar power projects in Israel and worldwide. Baron Raviv has developed unique expertise in the planning and installation of solar energy systems in remote locations. In recent years, Baron Raviv supported in the installation of more than 2.5 megawatts solar energy panels. Among our projects we can find the Beit HaShita project, Pvs&Br project, Kerem Shalom project, and few Army off-grid remote sites. The design of solar system started with detailed on-site investigation, checking the dimensions and the structure of every building we want to install the PV system on it. With all the collected data, the designer is checking if the structure is able to bear the new system on the existing roof and avoid any damages on it. The designer is checking shadows on cells and the correct distance between panels and existing objects. Beit HaShita project. System output 630 kilowatt. Date of installation August 2012. Build-up area 9,600 square meters. Type of installation rooftop. Solar modules 4,200 units of Frontier 150 watt. Inverters of SMA Germany. The uniqueness of this project was the limited installation area. We had to reinforce the roofs by using smart engineering. Pvs&Br project. System size 50 kilowatt. We did the installation on August 2012. PV plants covers the area of 210 square meters. Type of installation 2-axis trackers. 168 units of sun power PV plants, 305 watt each. Inverters by Kaku. The uniqueness of this project is that we were the first to build 2-axis trackers systems. Due to regulation limits, we had to install the poles on the ground, but make it look like it comes from the roof. Kerem Shalom project. 6.4 megawatt of ground-mounted system. On March 2013, we have completed the foundation stage. This system covers the area of 84,000 square meters. In this project, we are using about 28,000 units of photowatt PV plants, 235 watt each. Inverters by SMA Germany. The uniqueness of this project is that due to legalization requirements, we had to finalize the foundation stage within 1 month. Nowadays, we are about to complete the construction stage and to start the PV plant's installation. Among of all the large sites, we can find few small but important off-grid sites. Some of them working with DC directly from the batteries, but most of them with inverters for AC current. The uniqueness of those sites is the limited accessibility, the requirements to fit the high Army standards, and high reliability required for Army sites and security sites.
The Ministry of Science, Technology and Innovation in Panama, which is called Senacit, identified numerous ways in which renewable energy can be hitched for improving the life quality of the indigenous people in Panama, and initiated several projects in this domain. One of the projects is electrification of standard houses. The government provides people who lost their huts in floods with substitute houses. We recommended a customized plug-and-play solar system to enhance these houses. The system design is focused on a safe, plug-and-play, inexpensive system that can be deployed quickly in large numbers. The system is supplied with lighting, switches and electric outlets in a closed box that provides for high safety as well as protection from humidity and dust. The only thing required from the installer is the installation of 2 solar panels on the roof and connecting them to the box. Following a successful test of a demo system, over 100 systems have been deployed during year 2012. We expect large quantities to be deployed this year. Other projects that was initiated by Senacit is electrification of remote health centers. It is a common knowledge that health and energy are interdependent factors which largely determine the progress of rural development. In modern medicine, electricity provides a backbone for any functional medical center. Many indigenous people in Panama do not have access to modern healthcare that can save life, reduce the high infant mortality rate, and substantially improve their life quality. This is because the living areas are not connected to the grid and will stay like this for the foreseeable future. Senacit initiated a project of powering health centers in Comarca Gunayala and Comarca Noguebugle with renewable energy and equip them with modern electric medical appliances. Deployment of photovoltaic systems in equatorial regions like Panama requires special consideration due to the unique climate that includes high levels of cloud cover and precipitation. This becomes even more complicated when considering life-saving facilities such as isolated health centers that must enjoy continuous power supply with no interruption in this challenging climate. Overcoming these conditions is our expertise, as shall be described below. Our first project in Panama was the island of Carti. The Carti Health Center is serving approximately 4,000 people from the surrounding islands. It is a medium-sized facility built on the ocean shore, consists of 2 brick buildings with asbestos roof and 21 rooms. The project was completed in May 2012. In addition to powering the health center, we equipped it with modern medical devices and water purification systems. We conducted an intensive survey prior to installation. We found that following the deployment of the new medical devices, the daily energy consumption will be approximately 20 kilowatts per day. A hybrid system consists of 6.5 kilowatt peak solar array and 1 kilowatt wind turbine was installed. The system is comprised of state-of-the-art components such as Xantrex controllers and inverters, Deca batteries and Canadian solar panels. A large battery bank provides for up to 3 autonomous days. Shipping the system components that weighed more than 5 tons to an island accessible only with small boats, together with the poor condition of the asbestos roof and the high level of groundwater, raised complex logistic issues which we overcome due to meticulous planning based on the site survey. The system is continuously monitored to assure uninterrupted power supply. The Carti Health Center enjoyed an uninterrupted power supply throughout the last rainy season. We then moved to a project in an area called Noguebugle. The project includes 5 health centers in Comarca Noguebugle. 3 reside on the shore of the Caribbean Ocean and 2 on the bank of Rio Cricamola, about 25 kilometers into the rainforest. In addition to powering the health centers, we equipped them with modern medical appliances and water purification systems. Installation of renewable energy systems at the various health centers in Ogebugle is associated with substantial logistic challenges, starting from transportation of tons of expensive equipment through shallow rivers and ocean harbors, through unstable roofs, lack of water and communication, flooded yards, and substantial variation between the centers. In order to overcome these issues, we have conducted intensive surveys in all 5 locations and collected numerous details that help us to overcome these problems during construction. Following the deployment of new medical appliances, the projected daily power consumption of the health centers varies between 8 kW and 42 kW. Accordingly, the hybrid system ranges between 4 kW peak and 15 kW peak solar array and 1 kW to 2 kW wind turbines. All installations include large battery banks for backup during cloudy days. Following the successful installation in Kati, we have been assigned to a more challenging mission. The health center in Aligandi serves more than 4,000 people and handles more than 13,000 treatments annually. It comprises of 10 buildings and includes advanced functions such as X-ray, ultrasound, and operation room. During the site survey, we found that daily power consumption of the hospital can be as high as 180 kilowatt. This is a very high power consumption that raises complicated technical and logistic issues. Of further complexity is the fact that the hospital operates both 110 with 240 watt appliances. There are only few off-grid systems of this size worldwide, and the Aligandi power system is among the largest off-grid systems in the world. Israel's best engineers were hired to design the system. They came up with an innovative design, overcoming the complicated technological problems associated with the size of the system. The design includes 3 different subsystems with an aggregate of 50 kilowatt peak solar array and 4 wind turbines with an aggregate power of 3 kilowatt. Each subsystem is optimized for that particular load that it serves, and each subsystem has its own battery bank. We are sure that the comprehensive planning and design, combined with our vast experience as well as successful installation in Panama, will lead us to an outstanding success in this challenging and exciting project in Aligandi that will substantially promote the life quality of the people of Comarca Gunayala.